In the interest of time, I'm going to go ahead and get started. We still may have a couple of people jump in as the meeting goes along. Totally okay. For our speaker this evening, it is Mr. Derek Giardino, who is a senior hydrologist with the National Weather Service West Gulf River Forecast Center here in Fort Worth, Texas. He's been a forecaster for 11 years now, has a bachelor's degree in meteorology and a master's in civil engineering. Great at GIS, obviously, and has a lot of experience not only with forecasting from a hydrologic and meteorological perspective, but a lot of experience with decision support services and deployment, helping our partners make more informed weather and water related decisions. So with that, I will pass it off to Derek. You can go ahead and share your screen and take it away. We can't hear you though.
Sorry. All right. Can you hear me now?
Yes.
Can you see my screen?
Yes.
Okay. Yeah, I went to share my screen and everything moved. All right. So, hi, I'm Derek, and I work with Amanda at the National Weather Service. Yeah, I've been there about 11 years now. But I work on the riverside, but I did not tailor this to rivers or whatnot. This is a GIS-based presentation. I wanted to take you guys through some of the new cool tools that we have. If there's anything you can get out of this, I hope it's bookmarking some new websites to check out when you want to look into the next weather or extreme event. Basically, I'm going to take you through some of the basics of GIS. This won't be any kind of long lectures, only a few slides on what GIS is and how we use it with weather information. Where we'll spend most of our time is, well, how can you guys use it? What are some of the cool tools out there that you can get onto and use right now that are available? And then what are some of the tools that will be coming here in the near future that are actually right now in final phases of getting online so that we can get them to you guys. So we'll start really with what is GIS. And GIS stands for Geographic Information Systems. Usually we do this in person. Unfortunately, we're not. But I wanted people to try and think of what are some of the everyday examples of GIS that you may interact with. I have some that I have come up with myself, but this being an AMS chapter, a weather chapter, radar scope is a great example of GIS right there on your phone. It's information that you grab with that is geolocated. When we go on our traffic apps to get somewhere, that's all GIS information. When you go for a run, tracks it, that's all GIS information you're obtaining. Google Maps, satellites, one of the ones my friend came up with was Yelp. I go on the Yelp map to see what's the best restaurant. Well, that's a GIS map. That's what you're getting, geolocated information. And that's basically all GIS really is. GIS is a computer system that kind of analyzes and displays any information geographically, AKA it's data on a map. It's pretty simple. If you're seeing more than just a map, it's probably some kind of GIS involved with it. Again, we work for the government, so I had to flip it around to get on the government, conspiracy theories. What ways do you interact with GIS? And this may be something you're not aware of, but there's a lot more things that you provide to GIS systems than you probably use. Some of the examples I can, again, when you put in a Yelp review, you're contributing to a GIS system. You are giving them a geolocated rating for whatever restaurant, and it goes into their GIS system. When you drive, that Waze system actually uses your geolocation. Facebook is using geolocation services even when you try to turn it off, just to get metadata from where you're at. Geolocated photography, this way you know where you took your photos. Phones, when they try to find the service. But it's not just on your phone. TXU Energy during the ERCOT crisis last year, they know down to the street level who's using the most energy based on their GIS systems that you're contributing to by plugging into the network. Amazon, they changed their routes and delivery services and where to build certain warehouses based on their GIS information. Heck, even Netflix, if you were ever to see a random ad for some kind of show that you don't think you're watching, your neighbors are probably watching it. They actually geolocate their advertisements based on who's watching what in what neighborhoods. An interesting thing I learned looking up GIS. But basically, if you have location services turned on, you are contributing to a GIS system. So it's really interactive. And that's really what we're going to learn about today, is how you can interact with some of the stuff we can provide for you. I told you this wasn't going to be a lesson. This is your one slide on teaching you GIS. I tried to break it down into one slide, but if you ever see anything that looks like this probably means it's some kind of GIS system. Basically, it's just layers, and that's what you're working with, is just putting layers on top of layers on top of layers, and at the bottom is the real world or map, basically what is represented the real world. There are two types of layers. The raster, which is basically a grid, just a grid that covers the entire map. That's what a raster is, very simply. And vectors are data that take up, regions, they can be boundaries, they can be point data. That's vector data. They're just treated a little differently, so they named them two things that have nothing to do with what they actually are. Why they didn't just name them grid and point, I don't know. The layers can stack, so the user can interpret them, and also they can be analyzed together. You can analyze one with the other, and you can interact with them, and you can combine them and get more information out of it. And that's really where GIS comes to the forefront, is the way you can take multiple sets of data, analyze them, and output something that's easy to read. Examples that I put on here is like when you're on a phone, the cell phone points, it locates you and locates a point over time, keeps putting those points over time, and then all of a sudden it draws in the traffic time that it takes to get somewhere. That's all your geolocated services that you're providing to either Waze or Google Maps. And that interacts to how do you interact with? Well, when you put in a point in your GPS and you want to travel to it, it will give you the fastest route based on all those calculations it's done with other phones. Useful information. But how is it useful for weather information, which is why I'm here today. And I'm going to tell you that the meteorologists are GIS experts. We just don't like to tell them that. They have enough stress apparently on their own, but all of the forecasting software they use is technically GIS software. AWIPS, which is what they look at, the primary tool to look at data visualization and look at the forecast models, that's simply observed and forecast information on a map. And it can be done in the past, present, and future, but AWIPS is just one giant GIS analysis tool. Don't tell them that. They'll think they're GIS experts and put it on their resume. But then when they go to make the forecast, they use GFE, and it's very much the same thing. It's their interactive GIS software, so they can draw in areas and make rasters, and then they can save it up to the National Digital Forecast Database, which we didn't tell them, but it's just a GIS raster database. That's where all those forecasts are held, and all the information can be ripped away from. The only problem with the way that the Weather Service does it with their forecasts is that since it needed to be easily editable, the forecasters needed to be in there and be able to draw in where they think the forecast is going to be, where they need to make the changes. The output is not as easily ingestible as it is with stuff like ArcGIS or Esri or other GIS programs. So that's really the drawback of the GIS, but the Weather Service has been doing this for years and years and years before most of this stuff was available. So I wanted to break it down. I took yesterday's Fort Worth's graphic, and we can break down the GIS that's actually in it. You can see there are several layers here, even though it's a very simple graphic of how it did get unseasonably cold last night. It is mid-March. I'm tired of this cold. Didn't need the sleet today. Manta's going to need to fix that. But there are several layers on this map. You can see the gridded low temperature as a raster grid or grid data. All that little boxy pixelated stuff is the grid underneath. And then the point data that it actually pulls from is the temperature data that you can see at each one of the cities, and that's vector data. So GIS helped us answer weather questions pretty and very simply. So not only can tell us, what and where, which is what we typically use it, it can do when and why as well. It's just not as easily done in a simple one image. So I asked the question of we do GIS, but why talk about it now? And basically it's because in the past 5 years, we've substantially increased our ability to get it to you guys, to get it to the general public, to get it to heavy users, to get it to our partners, to get it to emergency managers. The advancement of cloud-based GIS has exponentially increased our ability to get this out to people. When I worked Harvey, I didn't have one tool, and now there is a fleet of information that's at my fingertips that I wish I would have had, down in Austin during Harvey. So that's how fast this stuff has evolved in the past 5 years. A lot of times GIS services are called API services. So if you see that mentioned in a website, there's API services available. That's what they're really talking about, is that there's some kind of GIS layer you can grab. And really, weather is kind of the best industry to push GIS. What other industry needs to tell you where in a grid format, or what's going on where in one simple way? And that's where ArcGIS comes to the forefront. And now I'm going to take you through some of the ArcGIS online tools that really take advantage of all this data being available and coming online. We get more and more data every day that we're just trying to keep up with. So that's what brings us to our important part, and I'm going to be more interactive. This is one of the few times that being online is actually going to be advantageous. So these are some of the tools that you can use. There are websites that work, and you can go on them whenever you want, and use them and look at GIS data. One of them is this hurricane tracking tool, and see if I can drag it over. Yeah, not happy with me. Where did it go? I don't know where it went. There it goes. There we go. So you can use this GIS data. Clicking on a point, you can go ahead and look at Hurricane Delta and interactively work with, when was the wind speed, where was it the highest, and the pressure that was elevated with it as well. You can see it moving on the land, losing some of its power, and then gaining it back over the Gulf before it made landfall last year. And this data is available for all hurricanes before 2020. And as soon as 2021 becomes available, it'll be on here as well. So any kind of GIS information from a hurricane, you can go back and search for this previous tool. Pretty neat and interesting. One made by someone in the office there is the actual tornado climatology. And this helps break down tornadoes and where and what counties they cross, what time of month they may be. We have an increase. You can see April, May, 509, 494. You can click on that, and it'll actually break down in the map where those where the May tornadoes were. And you can see the two EF2s came, EF5s came during May. So a lot of information you can easily grab out of these maps, and they're all interactive. You can click on anything and break it down. Any way you want, to search and go through the data. And I think Patricia, who works in the office, did an amazing job with this tool. And so I highly recommend, if you're ever curious what kind of tornadoes have hit through the area, use this tool. That's climatology. We'll go on to the next section, which is like, what is actively happening? Some active weather tabs. And the office also made an active weather tab, as you can see. This is the current weather that's going on, something you can just kind of tab through and get a quick glimpse, situational awareness of what's going on. Outlooks, forecast rainfall. Probably should have preloaded this before we got on here. I have about 10 of these loaded at once, so it does take some bandwidth up when I have that many open. But you can go through what day 1, day 2, day 3, and day 4 and 5 rainfall forecast pretty easily and quickly. You can see this is why emergency managers like this information. One-stop shop, can kind of go through, pick up what I need to get out of this, and move on with my day. So these weather tabs become very, very helpful for their situations. We have one as well at the River Forecast Center. If you're looking for more of a state outlook, we have very similar setup, 24-hour rainfall, surface maps are on here in case you want to look at that. And this one actually scrolls through at the State Operations Center every day. Some other ways we got, this is the one that I had at Harvey. We've been perfecting probably since 2016, 2017. This is our decision support tool, and this kind of puts it all together. This one, you can put together the real layers you want to see, and you can make your own map. All the layers that are possible around here. So they're not tabs to go through. You can actually pick which ones you want to look at. You can turn on and off layers. You can manipulate layers. You can change the order that they appear in. There are tools down at the bottom to change some of the statuses, get some summaries of how many river forecast centers or forecasts there are right now. Obviously, it's just a little geared towards the rivers and the flooding, but it has all information about it on board. This is available off of our website. Pretty easy tool to use. Pretty popular tool, actually, too. It gets about 2,000 hits a day. And then one of the things we've been using it recently for is summaries, event summaries. And the office there in Fort Worth uses it for event summaries, and so do we. Stuff like Hurricane Harvey. This is something you can just throw on your website and keep there as a living archive of what happened during Hurricane Harvey. And so a lot of people who, you get several events in and you want to remember, well, geez, what went back there? You can just pull this map up. It can take you through exactly what the weather pattern was during Harvey, why it got blocked, why it got stalled. All that information is in here and is available at any time to go back through, look through, and interactively play with. We did an end of the year review as well this year. And this kind of acts as our living archive. What happened in 2021? In 2024, I guarantee you won't remember about the dying Hurricane Pamela over central Texas, but the factors that came together that led to severe flooding on the Guadalupe River, this will help remind our staff and our team of what exactly happened and keep an active archive that's a lot more interesting than a whole bunch of saved forecasts. So I also wanted to kind of take you through what's coming in the future. There's some really, really cool stuff that's right on the cusp of coming out. Wish I could give you the websites to them, but they're on the brink. And one of them is the Safer Nation dashboards. Imagine having one of these dashboards, but depending on what kind of extreme weather event you have, you can click on it and get it custom made exactly for it. The Safer Nation is an example. Say you got a severe day, you can just go ahead, click on the severe one, and all the map will be customized to showing you severe weather outlooks, severe weather ongoing, which is really cool because then you can pick the type of map dashboard you want without having to click through layers or whatnot. SBC outlooks automatically come up, the mesoscale discussions, your high-res models that you want to look at. Satellites, we kind of collect it and put it all in one spot for you, so you don't have to open 1,200 tabs and go through it. We'll open the tabs for you. These are about to be approved, so they can go out to everyone, but I found these extremely helpful. And remember, I'm a hydro person. I made this Hydro 1, but when you hear of big wildfires going on, I don't know what to look at. I don't know where all the information is saved up. This gives you one-stop spot to just kind of go in like, well, geez, where are the wildfires and what is going on with them? And automatically you see, oh, we got incidents all over California that are going on, and you can click on them and get more information immediately on these wildfires. So you become a large amount of situational awareness very quickly using these dashboards. So you kind of can check out what the latest weather event is and how it may be interesting to follow. And then the last tool I wanted to share with you is obviously what I'm personally working on, flood inundation mapping. We're trying to change the way we look at flooding. We are so used to looking at the hydrograph from the RFCs that we forget that flooding is actually happening to buildings and structures. And so we've kind of created a dynamic flood inundation mapping situational awareness tool. Believe it or not, Texas has got the most flood inundation maps in the country, and not only that, but the most companies making them. We have up to 7 different flood inundation maps for a single site. Using GIS technology, I can easily tell Amanda which one we think is the best in an area. So say I think that Inform is going to be the best in Waco. we can just we share her the inform map for Waco for a potential 37-foot flood, and it shows her exactly which structures are going to go underwater. And then also it shows you how deep by just clicking on there, 2.5 feet. You can see the Baylor Stadium going underwater from the Brazos River. This is the kind of information that we used to have to type out in a text kind of format of, is this going to happen? Is this not? And now you get all of the information really quickly just by looking at this map. This is also in coordination with the USGS. This is FEMA. This is Corps of Engineers, all working together to try and get this capability. And I said it's not available yet, but it technically is a public website. So if you see a flood going on, you know, go to inform.us. I'm not allowed to physically put it on a thing, but it is available for all these sites. And hopefully soon will be the rest of Texas within the next 3 to 4 years, where all sites will have a flood inundation map for whatever flood. Go in, pop in, select the stage of the flood that's happening, and up pops up the map that's been created by an engineer. So with that, I will go ahead and just stand by for questions or whatever you guys have. That's what I had prepared for you guys.
Thank you very much. It's really interesting stuff. I'm a little partial to the part at the end, but it's all really cool.
I know a lot of people are big tornado fans in this one, and that mapping of information real time. I mean, the goal is to be able to get tornado tracks somewhere in that realm as well. Be able to GIS search tornado tracks so that emergency managers can get out there and know exactly what they're looking for, even in the dead of night. You know, where they need to be going as soon as possible. So, you know, it works with flooding, but it's going to be working with a lot of other severe weather as well.
Derek, this is Tim Marshall.
Yes, Tim.
Yes, is there like a one-stop shop, a URL we can go to then fan out and get all this information?
Not yet. One of the things I showed was this hub here. This is where we hope to house it, and it will be coming in. It's in the final process now to get approved. This is where will be the one-stop shop. You'll be able to get all these tools right from this site. But right now, where it's not approved, so it's kind of spread out all over the place.
Do you have an idea when you think this is going to be available to the public?
We're told probably June.
Oh, okay. So this year.
Yes.
Okay, great.
Hey, Derek, can you hear me?
Yep, I can hear you.
Yeah, this is Scott. I was just wondering if in developing your inundation mapping areas, are you using any high resolution LiDAR now? So much of that is becoming available in the state of Texas.
Yes, and it's fantastic. Let me tell you, because you think of inundation maps, the DEM is the most important part. It is what's going to define your physics. And so in cities like Austin and Houston, we have gone from the 10-meter DEM to the 1-meter DEM that is providing a lot more detailed results. We're just a little more weary of telling people their exact house is going to be underwater. So with great accuracy comes great inaccuracy, I guess you could say.
Yeah, fantastic. We've got some, I work with some half meter now every day at the office, and it's just amazing. It's hard to manage. It's so detailed, but it's great stuff.
Yeah, we're doing some new HEC-RAS 2D modeling, which uses the 1-meter DEMs, and to watch water move in some of these detailed areas is pretty fascinating.
That's great. Thank you.
Thank you very much, guys. I'll pass it back over to you guys.
I actually have one question. It's kind of a loaded question, but as far as the multiple years you've been working on the flood inundation mapping projects, what have you found to be the most challenging aspect up to this point?
Believe it or not, it's people having confidence in them, because it's been years and years and years since we advanced how people look at flooding. It took them forever to understand a hydrograph, and I think you of all people know that there's still people who struggle with reading a hydrograph, and now we want to just throw a map in front of them, and they have no idea what the inaccuracies, what the accuracies are. So they struggle to have confidence in using it. So we give them this beautiful map that tells them, Baylor Stadium is going to be underwater, and they're not going to believe us because we're working with a forecast which has inaccuracies. And on top of that inaccuracy, we're giving them a map which has inaccuracies, and we could be stacking inaccurate data. So yeah, it will take several years to get confidence for people to use it. That's the biggest hurdle. That, and if you're in a flood, Amanda, with 30 sites underwater, are you going to look at 30 different flood inundation maps? So prioritizing our time is also a shortcoming.
Derek, this is Tim again. With the forecast that you have with inundation, is there some way to extrapolate it into the future with the effect of that urbanization has on the watershed? The more and more that municipalities grow and the time of concentration of runoff is much quicker now. Is there a way? I know Scott Ray has done some work with future urbanization, and wonder if that's something that you guys are thinking about, so that you can say that, yeah, Baylor's going to be flooded out here with this kind of rainfall, but now it's going to flood all of Waco downtown in 15 years if there's so much urbanization with this watershed.
That is being, and so the model we are working with, the brand new one we got, is for the lower Brazos, which is down by Sugarland and Houston area. And the Sugarland spread, which is not a jam, it's an actual thing that's happening. They have to keep adjusting the model based on the impervious area of the spread of Sugarland towards the Brazos River. And so they keep updating it. And so they had the company, which is Freeze and Nichols, who owns that one, is doing the analysis of how much more can you spread before the Brazos rises too quickly. We're running with the current one. And as they make these newer ones, they share with us the potential of problematic issues in the future. And that goes to the Texas Water Development Board. And I think they're the real players, and can they make changes before we wind up shoving too much water in these areas that can't handle it. Right now, the fix has been to build levees, and they have a huge levee system around the Brazos, but that's only going to get you so far, considering we were only about 4 to 5 feet away from overtopping those levees in Harvey and the year after Harvey. So yeah, they're looking at it. As for us, though, we're forecasting with what's currently available, but we definitely see the spread, the urban spread of Houston being a huge problem, probably way more than it is in Waco.
Yeah, because I mean, I was hearing from doing Harvey work. I did a lot of flood work down there in the northwest suburbs of Houston, and not only were people caught off guard with regard to how much water they would get, but there was also some rumors, maybe, I don't know if it was actually found out, that certain levee systems were at least released either prematurely with their water or dammed up with their water. I'm not exactly sure which, but the contributions to the flooding from decision making on saying, okay, we're going to open up these floodgates and let this subdivision flood and not let that subdivision flood as much. And so using this kind of in a hindcast kind of thing and saying, okay, if you do A, you're going to cause this much damage. If you do B, you're going to do that much damage, and so forth. I think that's something that can be done, right, with using this information.
Yeah, and our new models. the one thing we couldn't do during Harvey's, we did not know that the Colorado River was spilling into the San Bernard River. And we didn't know that the Brazos River was spilling into Oyster Creek. We don't have a way to model that. And now we do. And it was because of that event, because of water leaving where it should go, then that this model showed us that this is what happened. So our next round of, let's knock on wood and hope we never have another Harvey, we will have the model that can move water around. In Louisiana, where they do blow levees and such to manage the Mississippi River, they have modeling too, to help divert that water so that we can forecast more accurately. But as well, it also shows where that water is going to spread when they do blow that levee. A lot of times they try to divert water into farmland. We, if you ask one of our forecasters, she said to make the San Bernard just a flood ditch. Divert all water from the upper Colorado and the upper Brazos into the San Bernard when there's too much, because there's nothing on the San Bernard River, but there's tons of people downstream in Matagorda and downstream in Brazoria County. So yeah, while we're not doing it yet, it's definitely a recommendation.
Yeah, a lot of those areas that I looked at had been swampland, 10, 20 years ago, and now mass subdivisions.
Yeah, we have greatly altered the river basins in the Texas Gulf Coast, greatly altered. Yep. And then we wonder why they all go underwater. We've tried to drown Houston 6 or 7 times in my career, and they keep staying. They don't get the hint. So, yeah, we greatly altered it to the point where it will flood almost about every other year if we don't stop the urbanization along the rivers.
It's really great conversation. Do we have any other questions from the audience?
Derek, this is Skip Ely, and I was in Jackson, Mississippi in 1979 when we had a big flood, and the water got higher than it ever had been before, and nobody knew where it was going to go, least of all ourselves. And we caught quite a bit of flack, of course, from local leaders, but I'm certainly happy to see all this kind of work coming to fruition, because we sure could have used something like that 40 years ago back then.
Yeah, and that office actually is helping leading the way and making some of the more advanced mapping systems for flooding. When we had a flood in Orange, Texas, probably about 6 years ago, Amanda worked it, she knows it. We were dead on with the forecast. We were so dead on, it was within the 10th of a foot, and they still had no idea where the flooding water was going to go. They had to evacuate a whole city of Orange, because they had no idea where the water was going to go. And when it finally got there, the Texas Task Force 1 walked around, putting their little poles in, measuring how much water was around and where it was, because we didn't have a flood inundation map. I mean, they had to evacuate completely dry areas, which the mayor was highly against. So yeah, we need these maps not only to help protect lives, but also to protect mayors from getting voted out because they evacuate areas that don't get flooded.
Derek, you said that a lot of this information has really come to the forefront since Harvey, and I'm wondering why. I mean, we've had GIS for quite a long number of years. Why has it taken so long to get where we are today?
Computer speed of the cloud is really what's improved. While we could have done this on a GIS system, to get it out to the public would have meant I would have had to save it as a static image, put it in an email and send it out. And that was just 10 years ago. And even when I did that, the model that I was using was nowhere near as powerful. So I guess it would be an advancement of the whole technology spectrum. HEC-RAS for flood inundation mapping is advanced head over foot to 2 and 3D, that we can get a much more accurate model. And on top of that, the GIS computer and the cloud can handle all the data at once and get it out to the public immediately. Like it's there. That's what I'm trying to to make with these GIS applications is it's just I don't do anything. We update our forecast, the map shows up online. Like that's how immediate it needs to be to respond. They can't wait for us to interpret the data, analyze it, create a map, send the map out, and then eventually they get a static map that's probably 8 hours old. So yeah, it's the cloud technology and the capabilities of technology and the new models that's really causing us to make this leap forward since Harvey. And the funding. Harvey brought a lot of money to make all of these models and all these capabilities. So where there's tragedy, there's triumph.
Hey, Derek, I have one other question real quick. I sit in on the CASA radar committee at Council of Governments, and they've done some really remarkable work with merging radar data with the Fort Worth stormwater people. And that's very much a kind of an engineering sort of model that they're putting together. So I'm kind of curious, in the early days of GIS, it wasn't really all that prominent as much in the engineering world. And I know you're a civil engineer. So I'm just curious how you've seen that particular aspect of engineering change as we kind of moved more into kind of the GIS and database related kind of data.
Well, with city planning, I think we're seeing a lot of that improved. Imagine when you're planning out your drainage system and you're able to see the prototypical rain rates, which is really more important than the total rain for a city. You know, if you could see a map of what is your average rain rate, what is the max rain rate that you can get. You know, Houston built their entire drainage system for 2 inches an hour. And if I could show them a map today, how often they get 2 inches of an hour, I think they would have designed it a lot differently. You know, that's the kind of GIS information we can really give them now. So when they build a new neighborhood, okay, we need to get sewage systems or storm sewer systems that can handle 4 inches per hour if we don't want it just backing up back into our neighborhoods again. And rain rate is something I'm huge on. I just feel that it's 10 times more important than the actual rainfall totals. And that's something that we can geolocate and give to people to show them where are the areas getting higher rain rates? What is the average rain rate? What is the 100-year rain rate that they can get? This kind of GIS information would help improve. And then when you do have backups in drainage districts, you mark them on a GIS and you see where is it repeat, and where do we need to funnel money into improving the drainage districts in those areas, all done, you know, in a matter of seconds. Instead of people having to file reports, rank reports, write the reports, and hope the report doesn't wind up on a bookshelf somewhere.
Yeah, thank you.
Any other questions? Okay, hearing none, I want to thank you again, Derek, for giving us the presentation. It was really interesting. It had a lot of insightful discussion towards the end. I'll get with you. We have a small gift to thank you for your time this evening. And yeah, so that's really all I have as far as tonight's meeting goes. We don't have any specific chapter business to talk about, other than if you haven't paid your dues, send the money in to stand. Yeah, that's about all I had. I hope everybody has a good evening, unless there are any other questions or comments anybody wanted to bring up.
Thank you so much. Thanks for the conversation. And Amanda, I will pass this presentation off to you if you want to spread it around so they can have all the links.
Okay, sounds great. We can attach that to the recording of the meeting this evening also.
Excellent.
Amanda, I have one question for you. When is the next meeting and you have to speak?
So the next meeting will either be the second or third Tuesday in April, and I'm trying to line out one of the broadcast meteorologists in the local market, but I haven't identified which one's going to be able to do it yet.
Thank you.
No problem. Well, I hope everybody has a good evening, and we will chat again in April.
Thanks, everyone.
Thank you.
Okay.